Twitch and doing all those things. So let's see if I can manage to switch over to my other screen correctly. All bets are off. All right, there's that screen. I'm going to go with that one. All right. So let's talk today not about revisiting animation right away, but let's start by talking about doing this. Oops. Not entirely what I wanted to do. There we go. Platformer. Not sure who's tuned in, but I'll try my best to pay attention to the chat and whatnot. We'll do our best here. And I'm going to encourage people to just ask questions out loud. And one of these days, I'm going to include a picture of myself in the corner, something like that. I was planning on doing that today, but then my computer crashed and everything went amok. So this is just a proof that this is live. This is tailored just to you, just for you guys. Okay, so anyway, let's talk about the Project 4, the final platformer, or the final project. We're in the home stretch, the last 4 weeks or so of the summer of the course. And so we're going to use everything we've learned to date, plus a bunch of other stuff. We're going to wrap in some other kind of cool features and abilities of Unity. And a lot of them, they definitely all have an applicability to whether, right now we're still focusing on sort of the 2D version, but these all have sort of 3D corollaries and other versions. If you feel really motivated to kind of do them in 3D platformer, okay, but make sure you're not biting off more than you can chew, and also make sure that you are meeting the requirements of the basic project as well. I've been showing on my YouTube channel and hinting at a bunch of sort of more advanced features, like using the bold programming language, the visual programming language, and using 2D renderers and using shaders and using all that sort of thing, and 2D lights and whatnot. That's not required. It certainly is not required of this project, and I'm really kind of introducing them, just we'll see. We're going to cover them a little bit more in the fall version of the course now that they're out there. And hopefully not taking this by surprise by as much. But for now, we can continue just using the normal built-in pipeline, built-in rendering, and we don't have to worry about 2D lights and that kind of stuff for now. So the goal, the requirements are normally that we're going to do basically a platformer or side scroller. Think of this as, everything before Super Mario 64 or Mario 64. And let's see, the ones that kind of broke the mold on platformers was, why am I blanking out? It's one of my favorite games, PlayStation, Crash Bandicoot. Yes, Crash Bandicoot definitely broke the mold a lot on what it meant to be a platformer, breaking out of the 2D side-scrolling kind of mold. And also, obviously, Mario did that as well on the Nintendo 64 when we went, everything in the world was 3D all of a sudden. But let's step back. We're thinking platformers more in the vein of, kind of, the Metroidvania sort of side of things. It's more the side scrolling. One of the big things that differentiate this from the last project is that physics is going to play more of a role, right? The main thing being that there's your normal sort of directional moving, plus there's one that you have not as much control over. You basically have a left-right move, and you have a jump and gravity. You push up, gravity pushes down. Those are sort of, you can also add in climbing if you like. But what I'd really like to see, looking for, is this kind of notion of you have a combination of scripted between the two. And along those lines, we're going to talk a lot about physics-related built-in features that you can use as you're developing environments, things like hinges and joints and effectors and that sort of thing. So that's also one of the big introductions you're going to see in here. So don't just abandon ship, try to entirely do it on your own, or make up your own spec. So let's talk a little bit more about this. Hopefully, if my computer behaves itself. So it's due basically the last day of class. That's the idea. Anyway, We don't have a final for this class, but it's due the last day of class. So we'll work around that as best we can. All right. What do we want to add? What do we want to do? All right. So one of the big things also is that we want sort of a larger world. It's tough to do, unless you're just doing Donkey Kong back in the day, where the world was just one screen. We also want to have more than one screen, so that we want to have some sort of deliberate camera motion. I know some of you, and I demonstrated in my basic kind of top-down platformer, this notion of really, really simple camera motion where you you make the camera a child of the player, and that's easy. And then the camera just inherits the motion of the player. That's super easy. We want to see you sort of hopefully kind of stretch your legs a little bit more in terms of camera control and how the camera moves throughout the world. And that's going to allow you to demonstrate things like, use of coroutines, use of interpolation, to create these kind of smooth motions and things, all kinds of kind of neat things. All right, so the camera will need to move and follow the player in a world that is larger than one screen. It could be something like a 3x3, or even a 2x2 would be fine. Something larger, so you have to manage the camera motion. You have to sort of manage the player's view of the world, and so on. All right. The player is going to have to navigate obstacles and climb and jump. Right. The last one, player may have hit walls, may have bumped into other things and had basic obstacles, but they really wasn't, you really didn't have to worry about, kind of getting around them all that much, other than just moving around them. So in here, we're going to talk about navigating obstacles, climbing and jumping, dealing with real physical things in the world that we're going to have to worry about. So there should be one sort of puzzle and one trap. And these should be implemented. By puzzle, I mean something really simple. You have to go to this part of the world and trip this switch in order for this motion to be triggered, or this behavior to be triggered in your effectors and hinges and so on, that sort of thing. Not necessarily, roll these tumblers into the correct position and so on and so on and so on. It's more just, you have to trigger an action through or you have to get something in motion based in reaction to a couple of, or one or more actions, deliberate actions by the player. And also, some sort of like one trap kind of thing, something that's preventing the player from advancing, right? So the trap could be all sorts of things. It could be spikes, it could be buzz saws, it could be so on and so on, that sort of thing. Now we do want to have enemies. We normally have, one sort of smart enemy type and one dumb enemy type. We got into that certainly in the last game as well, but we're going to get a little bit more into that now. And they're going to be, how they, hopefully you're going to be using a little bit more of inheritance and, again, stretching your legs on that one. And the goal is basically moving from platform to platform, some part of the world to some other part of the world, with some things you have to sort of solve your way around, find the key in order to get past this thing, and so on and so forth. And use a tile map. You may have already likely have already used tile maps in your last project as well. So continue on with that. Typically that's how we're kind of texturing the world through tile maps. A lot of bang for the buck in there. All right. All right, so camera movement. Think of things, you can always follow the player through scripting or through parenting. Parenting is definitely the cheating way to go, but scripting the camera is far more interesting and more cinematic. Now, you may have noticed, if you've gone through some of the packages and things that Unity has to offer you, there's something called Cinemachine, and a lot of games use it to kind of do these really sort of coordinated camera movements, like these really cinematic camera movements. So we want to do just scratch the surface of sort of what might be possible in there to kind of understand what goes into that. We're not going to use Cinemachine though. Don't want anyone using Cinemachine without really explaining to me why they're doing it. So if you guys, there's quite a few people who are doing some advanced stuff, maybe we do that, but by default, please don't use Cinemachine. I'd rather see you do a simple camera move on your own than something far more complex in Cinemachine. So you want to use coroutines and lerping to move and settle, that sort of thing. And you want to sort of follow the action. It's one possibility. Now, it might be you move from one screen to the next smoothly in reaction to event. If you've ever played some of the Zelda games, or there's plenty of other games where you trigger an event and then the camera swoops over or cuts over to some other part of the world to say, okay, the bars, the gates of that place opened, and then comes back to the player. that sort of thing. So it's kind of triggered camera motion. It's really kind of a cool thing. You also might want to do things like consider using camera effects. So something like shaky cams, or the classic explosion effect. If a bomb goes off, the camera shakes. Sort of things, right? That's also a great use of things like events, where you can have, okay, everybody's listening, or there's a whole bunch of things that happen as a result of a bomb blowing up. Certain things, maybe enemies run away, or maybe the camera shakes, or maybe the player slides, that sort of thing. It's neat stuff. And you can, use your imagination, but remember, don't make the player nauseous, or in this case, don't make me nauseous. So lots you can do. So following the player is the real simple one. You just change the camera transform position to match the player's position for the X and the Y values. So now here I'm talking about doing it not just by parenting it, by actually scripting it. Okay, so in the player's update function, you could just change the transform position of the camera. That's sort of the simplest, the basic scripting. At least then you can do things like, look to see, should you have constraints? Should be centering the player? Should we, make sure it's not off the edge of the world, right? So you can follow the player, but within reason, right? So it doesn't just keep the player in the center of the screen necessarily, or maybe it tries to, unless the player is towards the edge of the screen. So that's where it comes in handy. And be scripting these things and creating some sort of bounds that you can bump up against, right? There are also going to be situations, perhaps, where you fall off the platform. In the case of player death, you might need to create an object that follows the player, but only moves when they are not in the air, for example, to allow them to fall. So if the player falls, then, the player falls off the screen, and the camera doesn't just fall forever with it, sort of thing, right? Yeah, if the player cannot really change their Y position too drastically, you could also have the object maintain its Y position and only move along the X axis, for example. So you could do things like, track the X motion of the player, but not the Y motion of the player. Right? Interesting things to do. So you can have this sort of auto scrolling of the camera, which is simply putting a script on the camera that moves in a given direction at a given speed, requiring the player to keep up. Okay, so think of like Flappy Bird, sort of thing. The player or the camera just moves horizontally, and the player just has to sort of keep up. If the player doesn't, maybe the camera motion forces the player to move, keep it on the screen. Right? So think something like that, right? Has speed remaining constant, slowly getting faster over time, or dynamically adjust based on the distance from the camera, and so on. Right? Again, consider yourself, okay, what are you going to do when the player dies? Does the camera just follow them, or does it stay on the screen, and so on? Right? You could set up colliders along the edges of the camera. So you could do things like say, well, okay, if the player bumps the edge of the screen, then something happens, then the camera's behavior is different. Remember, you can have scripting on the camera itself to react to things hitting the edges and so on and so forth. All right, so get creative. Now let's talk about the obstacles. Obstacles and hinges and physics-based obstacles, I guess that's a good way to put it. So what are some of the types that you could include in your game? Well, platforms. Typically, you wouldn't have a platformer without platforms. And you can use them as environmental hazards or even challenges. They could be moving. They could be moving platforms. Platforms could be tied to buttons and switches. They might be falling. So if the user or if the player jumps on one without a switch being pressed, maybe they drop, and so on and so on. Right? Traps. They can create obstacles that the player must avoid or navigate past. Typically, the trap, if they trigger it, maybe rocks fall or things like that. Right? Other things also: spikes, rolling boulders, crushing pads, flaming jets, poisonous clouds, all those sorts of fun stuff. Right? Other obstacles: enemies. Right? You can spawn enemies with unique behaviors and patterns. They can be blockers. They can be active enemies and so on. So enemies sort of count as obstacles. But the main things we're going to try here, we want really talking about the obstacles that have sort of physics effectors and joints and things attached to them. But you can certainly have obstacles that are your enemies. They're static, patrolling, flying, ranged, melee weapons, explosives, and so on. All right. So remember, when you're creating an obstacle, generally it's going to be something that has collisions. It has physics, right? So we have colliders, we have rigid bodies, collider 2Ds, rigid body 2Ds. Even in the case of tile maps and so on, it's a matter of having the appropriate collisions, the appropriate colliders and stuff on them. Sometimes you have objects that just have colliders and don't have rigid bodies, but generally you're at least going to have colliders that you can be working on things. And a lot of the times the types of joints and things are based around physics. So you're definitely going to see more use of rigid bodies and colliders there. So to create platforms, you could have movement, could be set up similarly to the apple picker or using animations, right? So if you have platforms that move left and right, you could just script them, or you could animate them using animators. They could have their motion baked into them that way. So you can have platforms that move in a pattern, moving in some kind of set pattern continuously, or perhaps after a brief time delay, after each movement of the screen or a movement of the player. They could be activated. So you create some sort of button or switch that reacts to the player, colliding it to affect the platform or effector. They could fall, and you can do some fun things like adding animations for the platform vibrating first as a warning. So if the player steps on it, it sort of vibrates, and they have to get off before it collapses, sort of thing, right? Then you can also do things like even surfaces, right? Playing around with different types of surfaces. We saw a brief demonstration in one of the demos or lectures about using physics materials. So different types of surfaces can have different behaviors on them. So for example, you might have something that's slippery or bouncy, or, so if the player bumps into something, they wind up bouncing off at some kind of random way. So you can have sticky surfaces with more friction. Changes the materials on them. Right. And of course, the special note here, and this is where these are available and work for the player and object through the use of the physics system for movement. If you are just changing the position of the player, then the player is not going to react to these physics systems things, right? So if you're just using move position or translate without modifying the rigid body, if you're just moving the game object, it's not going to comply. It's not going to be affected by all these wonderful physics tools that we have. So it's going to rely a lot on basic traps. You can have static traps. Some traps might simply exist in the environment, affecting the player if a collision is detected, right? They fall into a pit with spikes, something happens to the player. That's a real simple trap. Bombs might be triggered, poison might be triggered, those sorts of things. That's more like a sort of the similar to the interaction between a power-up or a teleport or something like that. There's some sort of triggering thing and something happens as a result. Or you can have other traps that might follow some sort of set pattern. They could be moving, opening, and closing doors or gates or levers, things like that. And those would be they can be done either or animated via either a script or an animation. Right? So those are active traps, like rolling boulders, falling debris, crushing plates, burst of fire, that sort of thing. Or they could be reacting to the player, altering their behavior based on the physical, on the player's presence. And a lot of the physics-based traps will be the ones that really do that. So they can be set up via triggers on empty game objects as in the scene, or they can be set off by detecting the player, via ray collisions, that sort of thing. So once the player is sensed within a certain amount, it's sort of triggered, but you can also get more fancy in terms of finding, did the idol see the player? Did the beam of light hit the player? Did the player cross a certain path? Not necessarily a trigger, but you do other things like that, right? So there's a whole slew of these physics 2D components available to you, right? There are joints, right? And hinges, I usually refer to like hinges and so on, but I think the classification for most of them is really that they are joints. There are distance joints, which are designed to maintain a distance between rigid bodies. Hinge joints, which establish a rotational relationship between rigid bodies. Imagine, you have a door that swings around a certain hinge point, right? Or swinging platform, or even a chain where every link of the chain is at some sort of loose hinge that might swing in a certain direction. These rotate around either a static anchor point or a connected rigid body. They also have this notion of a motor, which kind of forces them to automatically rotate. Right, you built these built in. You can set limits to restrict the angle of rotation. You can create a chain with multiple hinge joints and a distance joint 2D at the end, for example. And let me show an example. Actually, I think I have an example of both of these things. So then we also have area effector 2D. We talked a couple of these. Area effector 2Ds, adding a physics joint, or excuse me, adding a physical force to an object that enters a certain area. So that's attached to some sort of 2D collider and is used by effector, and is trigger is set to be true. So this, you can refer back to these notes if you're trying to implement these. The settings can be tweaked to adjust the direction of force, the strength and variation, and so on. All right. So let me demonstrate we'll do a demonstration right after this. Point effector is also like an area effector, but at a single spot. So that's a little bit, there's going to be a lot of these. Some of these are going to be quite similar. Even distance joints and hinge joints have a lot of things in common. And we will not look at the end of this. Let's look at I have two platforming games that I've been kind of, because you should definitely set out some sort of design to this game as well, right? Do this early on. Figure out, how big is your world? What kind of things? Where are you going to kind of locate? Establish like placeholders and things. Again, through the exercise of creating yourself a little bit of a design document that you can refer to, so you know when you're going to be finished. What are the things that you set out to do? All right. So in here, I have a little world that I've created. And somewhere in here, we'll find our hero. Let me move the hero to a spot so I don't have to run quite all over the world. And this is a great thing to do while you're debugging, rather than make me run through the whole thing. And I'm going to just hit play here. And the player's going to drop down, hopefully, in near this thing I want to demonstrate. So, as an example, here's something I call the swinging ball of death. Okay, and if the player actually hits this, you'll see it is truly a physics simulation. You can totally interact with it, including kind of bumping your head. There's no damage caused, but you can kind of get it to do all sorts of interesting things. And this one, I have a step-by-step demonstration as another YouTube video. So I'm not going to talk too much specifically about this one. But this is I like it because it's a pretty good example of what's possible. So even though it's just 2D here, and these are just literally simple images, they are put together through a series of hinge joints. We'll go in here and we can look at them. So here's the swinging ball of a set of chain links. And each of those links, you'll notice, has on it a hinge joint. So it has a rigid body and a hinge joint and a capsule collider, right? So that the physics can determine exactly how this works. What the range of motion, like you'll notice if I click on the hinge joint, you'll see it has a certain range of motion. So it can't just totally spin around all day. That would be hilarious, I suppose. And it has, even now we start to get into things where you look at the rigid body 2Ds and the mass of each of these joints versus, for example, I didn't set an overall real heavy mass for the mace at the bottom. I thought I had. So you can do things like say, oh, okay, the ball at the bottom should be much heavier than the other links, right? So it's going to tend to fall down like that. So this is a pretty good what's possible with hinges and joints, right? So this is using a hinge joint on each of these with a different set of parameters, whether they be an anchored, like here, they're anchored to a specific spot. This one cannot move. It can just rotate, and everything is then anchored And there's a relationship between each of them, and that we'll see if you look at the hinge move down, you'll see that chain link 3 is connected to the rigid body of chain 2. And chain 4 is connected to chain 3, chain 5 is connected to chain 4, and so on and so on and so on. Right? So you can use these joints in all sorts of interesting ways to kind of create kind of complex things. Like I said, I'm going to leave the how to build one of those to my other tutorial. That'll give you a really good idea just to watch through there to get an idea for how hinge effectors work. Now, there are lots of different types of hinges as well. If you look at, sorry, not hinge, if you look at joint, you'll see distance joint, which is basically a relationship of how far two rigid bodies can be away from one another. Fixed joints, one is going to be, what is the relationship that they're held together with. Didn't mean to add that. Let's see. Friction joints, they can be held together by their overlap and how much they stick together. Hinges like the one I showed here. Relative joint is their relative position between one another. So you can have two things that are, oops, so now position from something there. Interesting. I don't know if it'll, from the camera. Interesting develop. There's a problem. So it tried to push itself away as this thing was doing. Interesting. All right. So don't do that. Don't use that hinge joint. Okay, where did that go? Did I put that on Capsule Collider? I'm going to just hit Control Z. Nope. Control Z again. Let's see. Edit. Undo. Edit. Undo add relative joint. Yes. All right. So now with that undone, everything should work correctly. All right. So this is a good example of a hinge joint. All right. Now, another joint or another thing in the scene, I mentioned the use of effectors. Now I kind of stuck to the wall there. You'll notice I also have some traps here. These are just simple animated traps. I just have to work my way around. Now this here, this particle, whoops, I turned it off. Let's see, make sure it's turned on. You'll notice if I touch this cloud of things just stopped. And there, nothing happens. I turn this on, touch that coin. Now, tricky with this in the way. Let me stop that. Where's that? We'll take that guy and we'll just disable him for the moment. And all right, we'll walk over here. Don't touch the buzzsaw. And you'll see that it will float up to the top here. Oh, you got hit by the other spinning enemy up there. So this is using an area effector. So if we look in the game here, it's an invisible object, and it has a particle system actually on it. This is called the fountain. I created a fountain. And there's a fountain trigger, which is that coin, right? So when you touch that coin, it turns this fountain object on and off. And the fountain itself has a buoyancy effector, right? So anything that is in the area there, right? There's the box collider. So anything that is in that area will become buoyant and float. And it'll float to the top here, right? So imagine if you had water, and this is sort of, the fountain, but imagine you have other sorts of water as well that you wanted the player to be able to float in. You could do that. So it's sort of an area effector, but it pushes in a particular direction, right? It interacts with it as a buoyancy. So buoyancy effector is an awful lot like an area effector, right? So you can see it's got flow, damping, and so on. Pushes things in a certain direction there. All right. Now, another thing worth mentioning here in terms of the character control, you'll notice, like the last game, we had the simple left and right motion, but we're also, our hero is able to move, to jump, right? So go back to the game for a moment. We can take a look at the player's motion here, right? So it has sort of a left and right. And what he does, he sort of tries to slow down in a certain direction. And if he walks off a platform, he will fall. Notice he has a jumping, falling kind of thing. Now, an important thing, you can't do an infinite jump. I think I made it so you can sort of do it if he's within around the ground. No, just a single jump, right? So you can't infinitely jump, and you have very limited control over your left and right motion when you're jumping, just like you would in the case of physics. Okay. So one of the things we have to do that is we have to get into this notion of being grounded, right? Of touching the ground. Now, if we use the built-in character controller, they have this kind of baked in for you, but we're going to deal with this specifically. And what you need to do is you have to be aware that certain character actions can only happen under certain conditions, right? And if the player isn't touching the ground, well, then it should be able to move side to side, for example, right? So the hero's behavior, let's take a quick look at that. Here's our hero. And we have a hero controller. And last time around, we used our ray casting, and we used, what did we do, a circle cast or a circle box? A circle cast to figure out whether or not things were spawning into a frame overlapping on other objects. So now we're going to use something similar to figure out, is the player touching the ground? Right. So in the update routine here, we're doing things like saying, okay, the first thing we do before we decide what is the player allowed to do, we have to check, is the player touching the ground? And the way we do this, the way I do this in this case, and there's lots and lots of different ways to do it with colliders. You could have it, if you actually, you notice I don't have a collision here, right? I'm not actually testing to see, did the player collide with the ground? So instead, what I'm doing is every time I potentially want to move the player in update here, I use the player's position, and I have a slight offset from that, which is in the Y direction. So we go down slightly from the player. So we're looking at the player's feet, right? And we create a small box, right? We have a certain size box that we project into the scene, right? And we see, right? So in here, in the game, I have a grid that has my platforms on it. It has the world on it and some certain things on it. But the platforms, if we look, the platforms are a tile map, and you'll notice they are on the ground layer, right? Other things, the world limit is not. The speed ups, oh, they are. Okay, so you can walk on those. The fountain trigger, none of the other things should be on the ground layer, right? Different layers. Anything that I want to be able to climb on or touch or interact with in terms of motion would be on that ground layer, right? So that would help me say, okay, if I am touching one of those things, I am allowed then to do my normal movement. I'm allowed to jump, right? So here's my normal movement up here, which is a left, right, similar to how we did it in the other ones, right? A little bit of a variation. I always like to add a little bit of personality to each of my character controllers. So we can get into that specifically later if we want. And the player in this case is allowed to jump. So there is an input button assigned to jump. And in order to jump, all it really does is it adds an upward force, right? Because the player is governed by physics, it's just pushing the player up. That's all that up does. And any momentum the player has, because it's using a force left and right to do motion. This is the nice thing about using physics for motion, is that all of the trajectories and the paths and so on, we don't have to worry about calculating parabolas and the lines and so on. They will be done. They will be performed for us by the physics engine, right? That's the nice thing. So that's why it is advisable to be moving the player by modifying, normally not even its velocity is a little bit tricky, but by adding forces in order to change its velocity or change its motion. Okay. And you'll notice here, just like in the other ones, I'm using my, flipping the sprite depending on what direction it's moving in. And also setting the walk left and right, depending, right? All right. Now, so that is the basic walk there. Now, it also says, all right, well, if we are touching the water layer, right, which is the fountain, we're touching water, we're allowed to do motion, but we're not allowed to jump, right? So this is so that if you're standing on that fountain, you can walk left and right. You can't jump, but you can walk left and right. And then finally, it says, well, okay, if you're not touching water, you're not touching the ground, we set the animation state for grounded to false, so that the animator shows us that little jumping or falling animation for the player. Right? So that's the character controller. Very simple, very, very simple character controller. It's left and right motion according to physics, a jump, which is just a force up in terms of physics, and then very, very simple ground detection by casting or overlapping a box at the feet of the player into the scene to see what it collides with. So that's simple segue into some of those other things. All right. Let's go back to, hopefully, feel free to unmute yourselves. I don't think I'm sending the microphone, the speakers, the microphones to the YouTube channel. It might be heard on Twitch, but oh wait, let's see. Someone has typed something into summer 2020. Crash. Oh, you're talking about Crash Bandicoot. Yes. Did I say crash? I hope I said the right thing. All right. All right. So let's get back here. And we will present again. There we go. All right. So can we use force in other ways for the president? Yes. It's the sky's the limit in terms of launch the player or on a hit or something like that. Absolutely. Any other sorts of physics interactions? I did that in the coin game, for example. When my player bumps into walls, it automatically gets a little bit of a push back. But I want to see you use the joints and effectors. But if you want to do other things with the force on top of that, absolutely. Especially if you have sort of weapons and things. But consider, go through and look at the forces, the effectors, the joints and things like that. So rather than coding something up, a custom behavior, consider, might it be easier using one of those built-in joints? Okay, so consider that. Especially, you can have effectors that you turn on and off. So if you have an enemy could have an effector, a force field on it or something like that, where it automatically pushes the player away, or a wall could have that, and so on. Right. So there are definitely things that you can do. But if you want to go above and beyond, by all means, do. All right. So distance joints, hinge joints. See, for enemies, you can handle the enemy's basic behavior as the same as the player, setting up different states based on what they're doing, in terms of animations. They can react to the player. So use raycast to detect when the enemies see the player, right? We want enemies to seem to be smart. They shouldn't just be moving back and forth. Otherwise, they're just dumb obstacles, right? So do things like using ray casting and line casting to detect, use the dot product like I demonstrated in the last project as well, so that the enemy will alter its behavior appropriately, right? Circle cast, ray cast, overlap circle, ray cast, hit 2Ds, and so on, right? Good stuff, right? And certainly now, the enemies should interact with the player. They should be able to attack. So to create an attack, you can detect collisions and give it an appropriate animation if that happens. So spot the player with a ray cast, then charge quickly at the player. If the player doesn't move out of the way, collide, and so different implications if that is what hits the enemy. And so you can get more elaborate in terms of things like ball of death. The player shouldn't die unless it gets hit, or maybe the player shouldn't get pushed unless it gets hit by the ball or something like that, right? It can fire periodically, just like did in the other one as well. It should be possible to defeat the enemies. Similar types of situations and interactions that allow them to attack. So in other words, it should hurt the enemies. There should be damage possible. Insta kills. We can be a little bit more sophisticated than that. Should there be a hurt state? Should they get angry? Should be pretty easy. You can normally just place pre-made assets. This is sort of the big, if you were doing a full-on 3D game, generally you're building a whole world and everything is sort of there by scratch, right? So in your game, you might find platforms, other environmental assets, and manually position them throughout, or you could procedurally generate a world. And this one can be really cool, but can be tricky because you don't want to generate unplayable worlds, right? So maybe you could, have a couple of platforms that are either there or not there, or make it possible that, there's definitely a way for the player to get through if they follow this path, but have some area reserved for some randomly generated path to kind of throw the player off each time, right? Until the player learns that, don't bother over there. Or maybe there's that chance that it generates a really easy path or a harder path or a convenient path. But there should always be some way for the player to play through without getting stuck due to some kind of procedural generation. Right. Like I said, pros, potential for replayability and lends itself to infinite game design, but it can require a hefty amount of coding and setup to make sure that it's possible to get through, right? And of course, you can use the tile map system sort of in coordination with either of those to paint assets onto a grid and then construct your level out of. Mention this. And there are ways, if you want to populate tile maps and even remove tiles on the fly. I don't know if I demonstrated that, but I had a feature. If you use the right combination of shift and clicking, you can delete tiles that you happen to be on. How's that for fun? All right. So those are our typical methods. So start off, before you get too far in, find some assets to get established sort of a theme. You can use them to complete your exercises. You don't have to use the same assets as your real levels if you just kind of kick things off. There are free asset packs they can obviously use. When you are placing assets, consider how the camera is going to move. Right, level will likely extend beyond a single screen, so make sure the camera will follow appropriately and not get stuck on certain things, or the player might get stuck on certain things. So take into account that the player can actually jump from platform to platform. Don't make it too difficult. I've run into lots of things where the player, it's really, really tricky to jump from one place to another because you wind up bumping your head or something like that. So tips and tricks here, vertex snapping. If you're building an environment out of blocks, you can use vertex snapping to easily line things up. So hold down the V key with an object selected, then mouse over one of another vertex and it'll drag right there. So that's kind of a fun tip. We used to not introduce tile maps until this project, but now I did introduce them earlier on, so I'm not going to spend too much time talking about it right now. But creating tile maps. We created tile maps. You use a grid to place your tiles. You can have multiple tiles. You can have multiple grids. You can have multiple palettes. Grids can be of different sizes. Grids will tile maps can be of different sizes, and tile maps can have their own things like their own collisions, their own colliders. And of course, each collider on there can have its own material qualities and so on. So you can get very elaborate with that. Right. And the all-important tile map collider 2D. One of the things, some people did mention this and ran into this. This is an easy one to bump into. Sometimes as your player moves along, and this is going to be far more important in this particular game, you'll notice that if you have a world where the player maybe is walking up a slope because there's a custom tile shape or moving along a surface, every so often the player might get stuck at an edge because there's like these infinitely small cracks in between the tiles and how the tile map colliders are created, right? That happens. So what you can do is you want to, it's a, what am I doing? It's a composite collider, that will combine a single collider, right? So, oh, there's intro project. There it is. So for example, if I go in the higher or the scene here and I click on the grid and we see the walls, they have a, yeah, it is. So, but if you have a tile map collider, it's also a good idea to have a composite collider 2D, which will take all of those boxes and kind of merge them. And what you should do in that case is just set the type of that rigid body to static. So then your tile map won't fall off your page, your game. That happens. So that's we've already gone ahead of time. We went ahead on creating tile maps, and there are separate videos for that. So I'm not going to get into the detail on there. Being here as a reference. I think everyone has done pretty well in using animation in their games. Okay, refresh the tile map colliders once in a while. Sometimes it doesn't update correctly. That's an interesting point. It should automatically regenerate them as you edit them. But so by refresh, do you mean, what exactly do you mean? In the, just turn them on and off? Using boundaries of tile maps. I've never seen that really become an issue. Well, it probably isn't a bad idea. I mean, tile maps, a lot of things to change and worry about on them. You kind of set it and forget it a lot of the time. So, all right. So that was a lot of love to demonstrate. And here was I think I believe I have a tutorial for this one as well. And I just want to mention or demonstrate this. And we're at about an hour, which is tiring me out. So I'm going to need a break. This is another platformer that I had been working on, which is sort of in a mixed state at the moment. But it has a cool feature, a couple of cool features in that it does have some 3D objects in it. So you'll notice this walking animation over here. And this capsule over here, these are 3D objects in the scene. And you can combine 3D and 2D in a game. That is certainly allowable. And I think even in this point, my camera is still an orthographic camera. So things are still being viewed kind of straight on, which means things aren't going to look awfully 3D, except for the fact that, which is kind of cool. Right? So you can bring objects in there like that. Now, the other neat thing in this game is I have created, there's a moving platform, I call the hook shot. And you'll notice our character here I can click on an object and it will draw a line between the character and that object. allow it to, and let's see, I think if I use the right mouse button, it will let go. And so we'll click over there. Whoops. Buggy version. So this is used with a simple spring joint in here. And what I'm doing is dynamically deciding what rigid body to attach the spring joint to. I think I have a tutorial going into that as well. So if we look at our hero here, we have, what is this hook point? I don't know what that is. Come on, hero, where are you? Player. So here's the player. And the player has a line renderer, which gets turned on and off to draw that line for the hook shot. And then it has a spring joint, which gets dynamically added to a rigid body, depending on when I click on something, at whatever point I actually click on something. So I use a projection there. If we look in hook shot here. So the cool thing about hinges and effectors is you don't have to just model them into the scene. You can do things with them dynamically, right? You can script their behaviors, right? So for example, in here, I can fire the hook shot and then figure out, using my mouse position that I clicked on, get the world position, figure out from there, draw a ray from my player to that position, cast a ray to see, okay, what is it that I hit? And then from there, okay, attach the connected body to the. Take a good look at what's possible with all the joints and so on. Okay, called compressed tile bounds. Haven't seen that. We'll have to keep an eye out for that. All right. So, you know, page or two, especially now that we're getting into things, you know, puzzle, track, elaborate environment, you know, figure out, okay, camera motion is going to do this, this, and this. You should be taking a little bit more time. So this might be worth a whole 2 pages of explanation and creating some sort of level document to figure out, you know, what's what in there. You know, are there going to be levers, hinges, you know, do you need any special animations and so on? I can hear I forget what happens is like these, I haven't looked at this one in a while. The platforms that are moving, there is my little lever over here. This was using a real primitive grounding system that I do not like anymore. It comes over here and he touches this lever, and I think that turned off some kind of interaction somewhere. This is a funkier game. I have another version of the hook shots somewhere else. It's a favorite of mine. I just love that from Zelda. All right, I'm gonna sign off the streaming. If you do have any questions, go ahead and post them to the Discord so that we can kind of discuss. If you want to discuss one-on-one, that's cool too. All right, thanks. Enjoy, and remember, yes, I guess no late penalties for any submission between now and Wednesday. So keep at, check things out, and I will start grading on Wednesday. So hopefully you've more or less got things done. You want to get going on the next project and building things in. But you do have some extra time if you want to polish things. If you feel really ambitious and you want to get into using the universal render pipeline and doing some lighting stuff and shading and so on, that's cool too. I got to let you know that's a lot of fun. And the whole Bolt programming language, visual programming language is out there as well if you want to check that out. Might be a lot of fun if you want to like tackle the last project using the visual programming language. That's make your, if you need more of a challenge for yourself, feel free. All right, take care. Good luck.